In this video, I introduce the fine-tuning language models from human preferences. Human labels applied to train a real-world model, and then the trained real-world model is used to optimize the policy model that has a similar performance as a human judgment. A pre-trained language model is first fine-tuned in a supervised manner on specific tasks and used as a baseline. The fine-tuned language model is further fine-tuned with reinforcement learning using a real-world model trained from human preferences. A language model rule defines a probability distribution as shown here and explained in this figure. This language model given x0 to x key minus 1 to predict the probability of x key. This probability policy model, given the article X, the model predicts the probability of the summary Y. If X and Y are article and his summary respectively, rho defines a probability policy via this formulation, namely generating a summary Y using rho given article X. A policy pi is initialized with rho and then fine-tuned to perform tasks using reinforcement learning. The goal is to optimize the expected real-world as shown here. The real-world model is trained by using human judgments as shown here. This real-world model, this human labeler, we use these labels to train the real-world model. Human labelers pick the best response to a given article X from 4 summaries, X0, X1, X2, and X3. From tuples X from X0 to X3 and B, loss of a real-world model is defined as here and explained in this figure. This language model rule, this linear output layer, this human labeler. We use the labels from human judgment to train the real-world model. The policy pi is fine-tuned using the real-world model R. The stable policy pi should not be far from the policy rho. The modified real-world is defined as here, where the second term is the entropy bonus for encouraging exploration. Follow several steps to train the real-world model and the policy model. First, sampling X0 to X3 via X and YI from rho. Humans pick up the best YI. Then real-world model R is trained on the human samples. And finally, policy pi is trained by the real-world model R via PPO, as shown here. This input article X and this pre-trained language model rho. This is the output generated from a pre-trained language model. And then human labelers generate these labels. Then we use these human labels to train the real-world model. And then we use the trained real-world model to fine-tune the policy model. Once we get the policy model, we can use the new input article X prime to generate a new summary Y prime as a human preference. For more details, please check with these references. Thank you. Bye.